Probably not surprising that pretty much every electronic gizmo conceivable has been incorporated into these rooms, all operated by remote control. At the touch of a button, televisions drop down out of the ceiling or pop up out of pieces of furniture. You can change the temperature, open and close the doors, change the mood, adjust the lighting, dim it, make it romantic. Let's leave it bright. So whilst all of this is great for the guests, it can be a bit of a headache for an electrical engineer.
Luxury calls for a lot of energy. Just the lights in one suite can draw more power than all the appliances in a British home burn in a whole day. And making the mood romantic could have shocking consequences.
So to dim the lights, simply press a button. Really not complicated, we're all familiar with dimmers. But simply pressing that button could have had a catastrophic effect.
The origin of the potential problem lies in what happens to an electrical current when you dim the bulb. It can heat the wires to abnormal levels and start a fire. To show what can go wrong when you're adjusting the ambience, we're going to check into my own replica of a luxury hotel room. I've brought electrical expert Paul Mitchison along to create a sophisticated lighting system.
Oh yeah, home from home. No, not back in the Burj Al Arab. This is my replica. There's no ensuite yet, or jacuzzi, or underfloor heating, but it's got a bedside table and plastic roses. Everything the modern luxury bedroom needs, including lights. Yeah, they don't really come on and off when you do that. That's just Paul out there operating them. Still, thank you. There it is, all working perfectly.
My shed may not be a fully authentic replica, but it has two crucial similarities. It has a high-voltage power supply for the electrical systems, and it has a dimming system. Paul, in addition to providing adult supervision, has set up a high-tech monitoring station, complete with a complicated array of gauges and test equipment.
Paul, to me, as a customer staying in my luxury hotel room, I mean, the lights are on, that's it. What actually is going on in there? What's happening?
So at the moment, what we're doing is we have a waveform that we can see here on the oscilloscope, and this is electric current, which is powering the lights.
Yeah.
And at the moment, the key thing to note here really is that this is a very smooth waveform.
So this is what a normal current looks like on an oscilloscope. It's regular and safe.
So a smooth waveform there, all right. But what if I change things a bit? This is when I want to change. That's a luxury bedroom, and I think that light, it's a bit harsh.
You want something a bit more cosy?
Yeah. So I'd like to change the light setting. I'd like to have, instead of 3 on full, I'd like to put 6 lights on, but dim.
Okay, so in that case, what we could do is we could dim those. We could bring up another 3.
It's a much better ambience in there. But just, am I right? That's the same amount of light. We just got 6 lights on, but lower.
That's correct.
So,
same amount of power into the lights.
We can see from the oscilloscope that something has changed drastically.
So what's different?
The problem is now is that we're delivering power to the lights in short bursts.
So
And
that's how the power's been halved then?
That's exactly right, yes.
Because I always thought it was like, a dimmer was like a tap. Because if you turn a tap on full, and then that's too much, you turn it down halfway, and half the amount of water comes out. And I thought a dimmer was the same. You just turn it down, and half the amount of electricity goes to the lights.
So it's more like turning the tap on and then off, and then on and then off.
Modern dimmer switches basically shut off the power to the light 120 times a second. It has the effect of not letting the light ever achieve full brightness. It also has a side effect.
So it's the same amount of electricity but being switched on and off very quickly?
That's right.
Well, why is that different? Why does that upset?
So the problem is that you're only delivering the power for a short period of time. And in order to do that, you introduce extra heating effects in the wires.
An electrical current in a wire always creates a certain amount of heat, but adding a dimmer switch can add extra heat to the wire, sometimes dangerously so. The on-off action of a dimmer switch creates so-called harmonic distortion, a sort of chaotic current in the wires, frequencies the system isn't designed to deal with. A wire heating up doesn't sound too ominous. It might smoulder away, but in the wrong circumstances, that wire can ignite flammable items close to it. If, for example, someone had carelessly left the exposed wire in a waste paper basket full of cotton wool, which might happen to be soaked in nail varnish remover, it could happen. With 6 lights on dim, let's see what does happen. Yeah, well, my hotel's on fire. Just so you know, that's a lot of heating. That took less than 20 seconds to catch. You really wouldn't want that in a top-class hotel.
The shed's on fire. You've ruined my hotel quite badly. Yeah, that is. I see your point. That is a potential problem.
Yeah.
Cool, blimey, bloody hell. Man, that's hot.
Obviously, this is a very exaggerated scenario. Electricians don't generally run exposed wires through flammable bins of cotton wool. But if it is a serious threat, how come dimmers are so common? Why isn't there a fire every time someone wants to change the ambiance? That could ruin the mood. It's because of electrical defences that include part of a camera's flash.
Yeah, I do see your point.
Yeah, it's not great, is it?
No, my hotel's ruined. So clearly, that needs to be avoided, and it is because they have dimmers, and that doesn't happen. So what's the solution?
So the solution is the capacitor that's in the camera flash. So we're all familiar with regular camera.
Early camera flashes used explosive powder to create the bright lights. But carrying that around was not for the faint-hearted. They needed a safe, portable alternative. And the solution came in the form of an electrical component known as a capacitor. In cameras, the capacitor stores up energy and releases it all at once, setting off the flash. But in buildings, combined with inductors, they act like filters, removing the chaotic currents that can cause fires.
This is a regular, relatively large capacitor. So this is the thing that allows you to take energy more slowly and release it back to the light.
But all that does is it accumulates this energy and then it releases it at a controllable rate and stops
that happening.
Burning your shed down.
I wish I'd known that 10 minutes ago. I'd still have a shed. The Burj Al Arab's capacitors are buried deep in the building. With the inductors, they are the unsung electrical heroes that protect the hotel from itself and its pampered guests.
I guess it is a relief to know that when I dim the lights, I'm not going to set fire to the Burj Al Arab. I imagine the bill would be quite big if I did. Yeah, I'd never get that through on expenses.